Chapter 2, Lesson 4 of Pre-Calculus, going to wrap up the lesson of looking at real zeros of polynomial functions by looking at the upper and lower boundary in which those zeros could occur. In other words, we talked about before the x-axis being the place where that represents all real numbers, and if the polynomial is going to cross, it can cross anywhere along that x-axis. Then we also looked at using the rational zero theorem to kind of narrow that down as to where the rational zeros could occur, but that leaves the irrationals that could occur anywhere along that axis. So when we graph a polynomial and we're looking at the places where it crosses or touches, how do we know that that graph doesn't turn around somewhere outside of the window that we're looking at and come back and touch the axis somewhere out beyond where we are actually looking? And there's really no way to prove that as far as from a visual standpoint, because no matter how far out you go one way, let's say if we're looking at the upper bound, like the largest number, how do we know there isn't another zero out beyond where we're looking? Or how do we know there's not a zero below where we're looking if we're looking at the negative side of things? So how do we know that there's no zeros beyond what we're looking at? So how do we know that? We're going to look at the upper and lower boundaries of a zero. And actually we have this test. It's called the upper and lower bound test for real zeros. And it's basically just using synthetic division to help us determine that. And basically it says this: if you have a polynomial that is a larger degree than 1, and the leading coefficient is positive, so there's a couple conditions here. All right, we can divide by a k. Right, we've talked about using x minus k dividing or synthetically dividing using that 0. If every number in the last line, in other words, after you do your division, and every number in that last line is non-negative, meaning it's positive or 0, then that k is the upper bound for the real zeros. There are no other real zeros above that number, so we know that we are that graph is not going to turn around outside of that number. Now I want you to notice something here about non-negative, positive or 0. 0 is not negative, but 0 is also not positive, so 0 is actually going to be in both categories, not negative and not positive. So that's the upper bound. The lower boundary would be, again, if we divide by a negative number. That's what this says. K is a negative number. K will be the lower boundary if that last line alternates between not negative and not positive. And again, it's very important to understand here that 0 is in both categories. It's not negative and it's not positive. So if for some reason you had a list of zeros, that would be alternating, not negative, not positive, not negative, not positive. Okay, so it's kind of a little kind of thing that happens with numbers you have to remember. So let me again state that maybe in a little bit a process for you to be able to do that, and then we'll do an example or two. So if we're looking at the upper boundary, the first thing we must do is that the k, the number we're dividing by using synthetic division, has to be a positive number. And the last line that I get after I do all my division, it has to be all non-negative numbers, so either 0 or positive numbers. If that's the case, then that k is the upper boundary. If we're looking at the lower boundary, that k must be negative, and then the last line has to alternate between not a negative number, not a positive number, not a negative, not positive, not negative, not positive. The key thing here to remember is that 0 is both not negative and not positive. Okay? For an example, we want you to prove that all the real zeros of this polynomial occur between -2 and 5. So -2 is the lower boundary. We want you to show that, and we want you to show that 5 is the upper boundary. So what we're going to do is simply divide this polynomial by each one of these numbers. These will be my k, and then look at the last line. So let's do the upper boundary first. So if I divide by 5, and sorry this is a little bit offline here, but so here are my coefficients. I bring the 2 down, then 5 times 2 is 10, and add, 5 times 3 is 15, and add, 5 times 7 is 35, and add, 5 times this, add, etc., etc., etc. Okay, so I did the division. This was a positive number. Notice that all of these are non-negative numbers. So because these are all non-negative number, 5 is the upper boundary. There are no zeros above the number 5. So now we want to look at the lower boundary for -2. The k is a negative number. So again, I do synthetic division, and then I look for, does it alternate between not negative, not positive? Okay, 2 is not negative, 11 is not positive, 14 is not negative, negative 14 is not positive, this is not negative. So it does alternate between numbers that are not negative and not positive. And because it does alternate, then negative 2 is the lower boundary. So we know then that the graph, here's negative 2 and here's 5, we have these zeros in here. I know for certain that there are no other zeros above this 5 and there are no other zeros below this negative 2. So this is the upper and lower boundary test for the zeros, are showing that the zeros are in a certain interval.